This is a computer mouse. This is also a computer mouse. And it's the most comfortable mouse I've ever used. But we can't see it. So what's going on here? So how do you make a mouse invisible? We have three possible options. We can use a trackpad which is inside the table. We can make the mouse out of a transparent material, or use a separate camera to detect the hand position and tell the cursor what to do. Let's set a few requirements for a mouse. We don't want any cables in the middle of the table like a wired mouse would usually have. We also want a very light mouse, so it's very easy to use. We need a mouse to be reliable and without any latency. We also want the shape to be as comfortable as possible to hold. We need the mouse to feel like a real mouse and not anything different. We also want it easy for everybody to replicate and use. And most importantly, it has to be cool. So that leaves us with only one realistic option: using a camera to see what our hand is doing. I admit I'm not the first one to do this. BasicallyHomeless and Guiny have already done this before. But hear me out. Guiny was struggling to use his design. It was unreliable and difficult to use. The homeless dude admitted himself that the mouse had noticeable lag. And the way he used his mouse was more like a trackpad than a real mouse. Which means, to satisfy our requirements, we need to do all of this properly. It can't be that hard. Anyways, here's what I have come up with. A webcam captures live feed of a selected resolution. The higher the resolution, the more the clarity, but it increases the data to be processed. MediaPipe, a machine learning library from Google, processes the video feed and tells us 21 different points in real time. So for moving the cursor, we see where the index fingertip point is and move the cursor accordingly. To click, we see if the tips of these two fingers touch and register it as a left click. If these two fingertips touch, it is a right click. The mouse is active if these two last fingers are open and the index fingertip is in the active area. But it all isn't this simple. MediaPipe and a few other libraries we are using need a few details about what they should work on. Webcam index. This chooses which webcam we want to use. 0 for built-in webcam, 1 for USB webcam, 2 if you have any other camera connected. Capture resolution. This tells OpenCV which size of video we want to capture from the webcam. CPU cores. This lets us change how much of the CPU is used. If a CPU has 14 cores, we want to use enough for high processing power, but leave a few cores to handle other tasks, like managing apps and keeping operating systems running. FPS. This sets how many FPS the tracking is limited to. It is always best to keep the FPS at maximum for smooth tracking. There is also an option to invert the controls, so that the mouse works fine even if the webcam is upside down. Model complexity is a tracking model MediaPipe uses. 1 is a good balance, but 0 can work on even the most basic computers. 2 is unstable and won't work. There are a few more things that we can change in the code, like tracking dead zones, margin width, etc. But they should work completely fine as it is. There are two windows that show what the mouse is doing. This one here shows the live footage, tracking status and a few key details. This dot is green if the mouse is active and red if not. The tracking FPS and minimum FPS are shown on the top. This indicator shows if a hand is detected. Confidence shows how sure MediaPipe is that it sees a hand. This shows the CPU usage. CPS are the clicks per second. And the mouse status is shown at the bottom. The second window is opened and closed by the backtick key. This window shows all the key details and can be dragged to a convenient position. The quit all button here shuts down the whole program. But does it work? Actually, yes. It works so well in fact that I edited this whole video using the invisible mouse. Okay, let's talk about the hardware required for this project. The webcam I have used is a Lenovo 300 FHD webcam. It records at 1080p 30fps and has a wide viewing angle. It is a very adjustable webcam and I have used this for a previous project as well. You can use any other external webcam and the code will run just fine. Built-in laptop webcams also work well. The laptop I am using is an Asus ExpertBook with an Intel Ultra 5 125H CPU. It has 14 cores which can easily run this tracking script using only 12% CPU power. I also tried this code on a very old Intel i3-7100U which has only 2 cores and it still worked completely fine. Even though I tried to make this mouse as good as possible, there is still plenty of room for improvement. But there's one question: how do you use this code? This code runs on only Python versions 3.9 to 3.12. The newer versions of Python do not support MediaPipe well. So I recommend installing Python 3.10 from the official website, link in the description. But if you have some other versions of Python, no problem. Install Python 3.10 as well. Enable add to path and long path option. Then we open command prompt. If you have only 3.10 installed, run this command to install the libraries. This can take a bit of time. After this is done, you can download the code and run it directly from Python ideally. If you have Python 3.10 along with some other version installed, every time we run the program, we need to create a Python 3.10 environment. In command prompt, we run these commands. This one creates a 3.1 environment. This command activates the environment. This command upgrades pip. This installs the libraries. Please wait patiently until it completes. Then we can download the code which is linked in the description. Make sure that the code is saved in downloads. This command helps command prompt find our file. And then finally we can run this command to start the program. If you have multiple versions installed, make sure that these commands are run only in command prompt. If you need any help in running the code, feel free to ask in the comments section. Here is another video if you're interested in Python and computer vision. I am Arif and this is More Amps.